Alright, hello guys, and welcome back to the Engineering Principles Advanced course. Today we're going to be talking about Newton's three laws of motion. Now, Sir Isaac Newton did, of course, come up with a lot of physical and mathematical concepts and laws, like his laws of universal gravitation, which we know as gravity, and he actually came up with calculus. But for today and for this course, we're just going to be focusing on his three laws of motion, since those will be all we need to understand the remaining concepts here. So his first law is that an object will keep its motion unless acted upon by an external force. So this makes a lot of sense to us logically, and in fact all three of these should make a lot of sense to us logically because we see them in action every single day. Take a box, for example, that's laying on the floor. If you leave the box there, nothing's going to happen. It won't magically start moving because it can't. But if you give it a push, for example, to the right, the box will start moving to the right. But this also has a slightly more interesting application. And for this, we're going to have to use what my physics teacher calls our mind castle. Basically, take what you know of the world and think about it in your mind. Imagine a theoretical world where friction doesn't exist, for example. That's called using your mind castle. So let's first think of just a regular world, and let's say you roll a ball along the ground. What happens? Well, the ball starts with a certain velocity, a certain speed, and a certain direction, and it starts to slow down. Then it slows down some more, then some more, and then eventually it stops. Well, what brings it to a stop? Because as we know, an object will keep its motion unless acted upon by an external force. This means that the ball should keep its same velocity, the same speed and the same direction, but it doesn't. Well, what's stopping it, of course, is friction. Friction is a force. The ground is applying a frictional force to the ball, which slows it down and eventually stops it. So let's say we took away friction. Let's say we had a perfectly flat, zero friction surface, and we rolled the ball along it. What would happen then? Well, the ball would keep rolling, and rolling, and rolling, and it would never slow down. That's very important. It would keep the exact same speed and the exact same direction, meaning it would keep its same constant velocity. That's basically what his first law states, is that if there's no force acting on an object, it will keep its current motion, be that rest or not moving, or be that a certain velocity. So Newton's second law we covered a bit in the first Engineering Principles course. If you didn't watch our video on that, please do go back and have a look at it. But very simply, it states that the net force on an object will be equal to the object's mass times its acceleration. It's a really, really important formula in physics, and one that we will be using in the future. And his third law is one that I'm sure everyone's heard at some point, is that every action has an equal and opposite reaction. The wording on all three of these laws, by the way, aren't exactly how I have them written here. I've simplified them down just a bit to make them easier to digest, easier to understand. So for this third law, let's look at an example here. We have two people pushing, we have two people here with their hands against each other. And let's say the person on the left pushes with 5 newtons. We have his force with a red arrow just because he's the person who pushes first. Well, think about it. If you've got these two people on Earth, the other person is going to push back. And that's not a voluntary action. Let's say if they were on ice or some completely flat frictionless surface. Think about this in your mind castle. If the first guy pushes, he's not going to stand in place while the other person starts moving backwards. They're both going to move backwards. And if they have the exact same mass, they'll move backwards with the same acceleration. That's basically what his law is. For every force, every action, there's an equal force or action in the opposite direction. So for this guy pushing to the right with 5 newtons, the other guy is pushing to the left with 5 newtons. Now hopefully that helps you understand Newton's laws a little better. Thank you.